Hi, this video is part 5 of model building. So let's see the agenda of today's lecture. We will develop some skills such as assessing model quality, and we will see different methods of evaluation. So let's move forward. What is actually model evaluation in R? Model evaluation in R refers to the process of measuring the performance of a statistical or machine learning model. The goal of model evaluation is to assess how well the model fits the data and how well it generalizes to unseen data. This information is used to determine the quality of the model, which helps in deciding whether the model is suitable for use in practice or not. The choice of evaluation metrics will depend on the type of problem being solved and the type of model used, such as you may be solving a classification or regression problem, or the model can be random forest, logistic regression, linear regression, etc. It's important to choose an appropriate evaluation metric that accurately reflects the goals of the modeling problem. Now, what are the metrics for model evaluation? There are many metrics that can be used to evaluate the performance of a statistical or machine learning model in R. Some of the most commonly used metrics include accuracy, R squared, root mean squared, and ROC or AUC, which represents sensitivity and specificity. So, what is actually accuracy? Accuracy is a widely used metric for evaluating the performance of a classification model in R. It measures the proportion of correct predictions made by the model and is calculated as the number of true positive and true negative predictions divided by the total number of predictions. Accuracy is simple and intuitive metric that is easy to calculate and understand. However, it can be misleading when the class distribution is imbalanced, meaning that one class is much more frequent than the other. In such cases, it's often better to use other metrics like precision, recall, or the F1 score. Or you can also use the techniques of such as downsampling, upsampling, and smooth to handle the imbalanced dataset. We'll study about these things in detail in the practical session. So next we have R squared. R squared is a commonly used metric for evaluating the performance of a regression model in R. It measures the proportion of the variance in the dependent variable that is explained by the independent variables in the model. The R squared value is a number between 0 and 1. Higher R-squared values indicate a better fit, with values close to 1 indicating a very good fit, and values close to 0 indicating a poor fit, such as a value of 0.9 is a good R-squared score, and a value of 0.4 is a bad score. However, it should not be used as the sole criterion for model selection, as other factors like model interpretability and overfitting should also be considered. So let's move forward. Next, we have RMSE. The root mean squared error is a widely used metric for evaluating the performance of a regression model in R. It measures the average difference between the predicted values and the actual values, taking into account the magnitude of the differences. The RMSE is sensitive to large differences between the predictive values and the actual values, making it a useful metric for evaluating the model's performance on larger errors. However, it can be sensitive to outliers. Outliers are basically the most extreme values or strange values in your dataset, and it's not always directly interpretable, as the units of the RMSE are the same as the units of the dependent variable. Lower RMSE values indicate a better fit with values close to 0, indicating a very good fit, and high values indicating a perfect. Then in the last we have ROC, which stands for Receiver Operating Characteristics Curve, and it's a widely used metric for evaluating the performance of a binary classification model in R. The ROC curve plots the true positive rate against the false positive rate at different classification thresholds. The TRP, also known as sensitivity or recall, measures the proportion of positive instances that are correctly classified as positive by the model. The FRP, also known as 1, or you can say specificity, measures the proportion of negative instances that are incorrectly classified as positive by the model. The ROC curve is a useful metric for evaluating a model's performance because it provides a visual representation of the trade-off between the TRP and the FRP. By changing the classification threshold, more or fewer false positive predictions, and the ROC curve shows the resulting TRP and FRP for each threshold. So now it's time for a hands-on session. Let's move to our studio to see how these evaluation metrics works. So first of all, let's use the accuracy metric on a machine learning model. But before that, I will have to load the required packages by saying library and then caret. And similarly, I will say library and MLbench. Now, I have already installed these packages, so you might have to install these packages at first by saying install.packages, and here you will provide the name of the package, and that's how you can download it. All right, let's load them. Now, first of all, I will load the data set. I will say data, and here I will say Pima Indian diabetes, and here I will say head and Pima Indian diabetes. Now you can see your data set here. What I want to do is to predict this column of diabetes by using all of these independent features. All right. So first of all, let's do the resampling. I will say control. And inside this variable, I will use the function of train control. And here I will pass the method of cross-validation. And the number for that should be, let's say, 6. And next, I will create a variable of fit. And I will say train. And here, first of all, I will say I want to predict the diabetes column, and I want to use all of the variables for the prediction. And here I will pass the method equals to GLM, that stands for logistic regression, and the metric for the performance or evaluation of metric should be accuracy. And in the last, I will say data equals to female Indian diabetes and TR control, train control should have this variable. And now let's say print, and here I will pass the fit. Let's run it. Now you can see that there are 2 classes that were used for prediction, and there were 768 samples in total, and there were 8 variables for prediction that were independent variables. There were 6 folds like I mentioned above. You can see that the accuracy of your model is 0.7, and kappa, that stands for, like you can say, the normalized accuracy for classification is 0.4. So that is how you can evaluate your model. Now let's move forward. Let's see the next metric, which is root mean square error and R squared. So first of all, I will say head, and here I will say empty cars. In this dataset, let's predict the MPG using all of these columns or some of them. So here I will say, first of all, I will do the resampling of the dataset. All right. I will say control, and here I will say train control. And inside this function, I will say method equals to CV and number equals to 5, which I want to use for my cross validation. And inside this variable, let's say fit to, and I use the train function, and inside that I say I want to predict MPG, and the variables I want to use for the prediction is cylinder and displacement and horsepower and in the last weight. All right. Now here I will pass the dataset. Data equals to empty cars and method equals to LM, because I'm going to use linear regression model. And here I say metric equals to, and the metric is RMSA. All right. And in the last, I say train control equals to control. Now let's say print and fit to. All right. Perfect. You can see your RMSC of the model here, which is 2.7, and R squared is 0.8, which is good, but not excellent. If the value is 0.9 or close to 1, then it means your model is performing good at predictions. However, RMSA or mean absolute error should have the value low or close to 0. Now let's move forward and see the metric of ROC, which stands for Receiver Operating Curve. So now let's load the dataset of Pima Indian diabetes once again. And let's say we want to predict diabetes once again. So just like usual, I will do the resampling at first. I will say control, train control. And here I will say method should be cross validation. And the number should be, let's say, 5. And here I pass some additional parameters such as class probabilities to the value of true. And in the last, I say summary function equals to class summary. All right. And here I will say fit free. And I will repeat the same procedure after saying the train function. I will say I want to predict the diabetes and I want to use all the variables for the prediction. And here I will pass the data, which is Pima Indian diabetes, and method should be logistic regression model. And the metric is going to be different this time. And it will be ROC. And in the last, I will say train control equals to control. Now let's print fit free. Oh, I forgot to remove these braces. All right. and here let's say GLM, because GLM represents logistic regression model. All right, great. So you can see a ROC curve of 0.8, which is actually good. It's close to 1. So that is how you can evaluate the performance of your model on prediction of classification or regression. Now let's get back to slides. So here's what we have learned today. What is model evaluation? And in the last, we have seen different methods for assessing models' performance. So you can assess the dataset by clicking here, and this is your homework. You have to first clean the dataset and then use different evaluation metrics to see model performance. Now, good luck. See you next time.